Chapter 6, Section 2, so we're going to look at law of cosine. So for law of cosine, we're solving the two situations from 6.1 that we were not able to solve with for law of sines. And that's side, 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 and side, angle, side. And then we're going to be able to find the area using all three sides as well. So here are the formulas for law of cosine. I'll be giving these to you on quizzes and tests, so no fret on actually memorizing them, but make sure you understand them. For this one, we're using this one for side, angle, side, because it's going to help us find the missing side. And then for 3 over here, we're going to use it for side, 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 because you can plug in the three sides to find an actual angle. And so that's how these formulas are going to be used. For the first example, side, 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 so you're given the three sides, we first need to have some understanding about what the triangle, what's happening with this triangle. And so when we look at it, I'm hoping that you realize that because 12 is the largest side, then C has to be the largest angle. You always want to find that first. Always find the largest angle first. The reason why is because the largest angle, if it's obtuse, then you know the other two are going to be acute. If the largest angle is acute, then you know the other two are going to be acute. So if you find your largest angle, then you're for sure going to make sure that the other two angles you find are acute, which eliminates the ambiguous case. And so for this problem, we're going to just plug it into our formula for side, 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 so we can choose to find angle C first right here. So cosine of C is going to equal a squared, so that's 6 squared plus b squared minus c squared all over double a times b. And so you evaluate this fraction first. When you do that, make sure you find the entire numerator and the entire denominator. And so if we find that value, we get the cosine of c equals the 44 over 96. And I think you get a negative value for that. So interesting thing about this negative value, I already know what kind of angle I'm dealing with. And it's because if you look at the unit circle for 180 degrees, and that's all of our angles of a triangle have to be between 0 and 180 to make a triangle, because the three angles of a triangle add up to be 180, so it can't be anything greater than that. If we have a positive ratio, then we know the cosine is positive in this quadrant. If we have a negative ratio, we know the cosine is in this quadrant, so we know we're dealing with an obtuse angle greater than 90. And so it kind of brings back our unit circle knowledge and deeper understanding. So I already know I'm going to have an obtuse angle here. So I'm going to do the inverse cosine of this ratio. And we find our angle is 117/2800ths of a degree. And so that's our angle C. Now once you find that angle C, we already know the other two angles have to be acute, and we can just use law of sines. So we can say like this, sine of 117.28 over 12 equals the sine of b over 8, and then just cross multiply to find that. So if you want to try that, you can. The solutions would be these values, so you can see if you're able to plug those in correctly. Okay, second example here is a side, angle, side. And so the first we need to find is the side opposite of our angle. So we're going to actually have to find our side A. And to do that, we need to use law of cosines. So a squared equals 16 squared plus 12 squared minus double 16 times 12 times cosine of 80. So then we need to evaluate this. When I evaluate it, I always find the sum of these squares first. Then I find this product, including the cosine, second. And then I'll do the subtraction third. So make sure we follow up with operations. After we find that value, then we need to square root it to find A. If you do that, you should find A is approximately 18.26 hundredths is the value for A. Now once we know this, we could think about the triangle, what this means. Now if you ignore the 12, if I cover that up, this actually ends up being the angle side problem from law of sines. Now we do know it's 12, which helps us out greatly, but if it wasn't, we could think about what does it mean for this triangle. And so we'd have like the altitude is right here, but how does 18.26 compare to 16? It's greater, so I already know I have one triangle. So, and because we have 12, we're only going to have one triangle, but we want to make sure that we don't have the ambiguous case. So this thought process does help me out. So we could just use law of sines then, with the 80 and the side opposite now, to actually find the rest of the formulas, or the rest of the measures. And so I'll let you do that to save some time, but here are the results you should have if you want to check to make sure that you're doing that correctly. After you find the side opposite the angle, use law of sines to find the other measures. Okay, for this one, the same process. You're still going to find A. So if we do this, same thing, evaluate square root, you're going to find your A value. A value is 5.4072. And so that's A. Now this is smaller than 9, so if you look at what it could be here, if you're looking at using the sines, we have to be a little careful, because the law of sines for this one, it actually ends up being, if you look at your height, so 5.402 could lie within here. Now the issue is, if it lies within here, then 12 is too big. So we know that's not a possibility, but the math will give you a second triangle if you're not careful when you're evaluating that. So to help us out, to make sure we don't have that, we can use law of cosines. And so if you use law of cosines once here, you're going to use law of cosines a second time. Now we have the three sides. So if you use law of cosines to find the largest angle, C, and then you'll make sure that you do not get the ambiguous case. So law of cosines eliminates the possibility of the second angle, again, because for law of cosines is positive here, negative here, two different values, where law of sines is positive and positive for sine. And so law of sine gives us two angles for that positive ratio. And so we got to be careful with the ambiguous case. And so if we use law of cosines twice in a row, you will never have the ambiguous case. That's the nice thing about law of cosines. So we use law of cosines once here. We can do it again to find angle C. Cosine C is going to equal 9 squared plus the 5.4072 squared minus the 12 squared all over double times 9 times the 5.4072. And so then you can evaluate that, do the inverse cosine of both sides, and you'll find these values here. You'll find the C value of actually 110.3. So kind of nice. If you use the law of sines to find it, you might have found the smaller angle when you've tried finding C. You might have found an actual value of 19.7. So if you did use the law of sines and you found the 19.7, you need to question yourself. So this is like your critical thinking skill. Does it make sense? Do these values down here make sense for the triangle? So B is the largest angle in the second triangle that you end up coming up with, but it doesn't make sense for the drawing because C is supposed to be the largest angle because 12 is greater than 9. So you would have to realize that this second solution that you come up with is not a solution, it's only this first one. And so there's two ways to do the problem here. If you use law of sines, you may come up with a second triangle and you need to think about does it make sense or not for the drawing. The first option, which I prefer, is to use law of cosine twice just to ensure I don't end up with an ambiguous case. Law of cosine will not give that to you. Good application problem. So you're traveling 40 miles east. So if we start here and we go east 40 miles. And then you change directions. It doesn't say northerly, southerly, so you can make a choice there. I'm just going to go northerly here and then drive 30 miles. So it doesn't say if I'm coming back towards the beginning or away, I'm not quite sure. And then you end up 56 miles away from your starting spot. So not a very good triangle, but we'll use it. So this is what I end up getting. You could also go southerly as well, 30, and then end up with 56 as well down here. So there's two triangles you could make for this drawing. But for both of these, you're given side, side, side. So we want to find, the question is, find your bearings from your departing spot to your ending spot. So this is our departure spot. This is our end spot. So what's our bearing? So our bearing always goes from like north south. So if I draw this, so we're going to go north and then we're going to go east. And so we kind of make this triangle. We make this triangle. This is the angle we'd actually want. Or if you want to go south and then east, you'd want this angle here. And so those are the bearings you'd actually want, not the angles of the triangle. But we need to find the angles of the triangle to find the bearing. So this is the angle we'd actually want because these two would have a sum of 90. They're complementary. And so if we do side, side, side to find the angle opposite of 30, so let's just call this, I'm going to call this A in the triangle. So cosine A, and then, so here is our formula to find the cosine of A. And then if we, again, we evaluate the numerator, evaluate the denominator, divide to get our ratio, then take the inverse cosine, you'll find that A is 31.1 degrees is what our angle A is. That's not the answer though. We want this angle here. And so we could call that north 58.9 degrees east is one answer I take, or I take south 58.9 degrees east. Because we're not sure which way we go when we change directions, northerly or southerly. So those are two possible answers for this problem. Area. So for area, for side, side, side. And so to find area, we're going to be using what we call S. It's a semi-perimeter. So you add up all three sides, which is the perimeter, and you divide by 2. So you're taking half the perimeter. That's how you find S. Once you find S, then you plug that into this formula to find the area of the triangle. Kind of a nice way in real life scenarios, because if you have a triangle, you can measure that quickly with a tape measure, and then you can plug in here to find the actual area, and you don't ever have to mess with your angles. And so this would be 5 plus 9 plus 8 over 2. So that's 22 over 2. So our S value here is 11. And so for the formula, it's going to be 11 times 11 minus 5 times 11 minus 9 times 11 minus 8. If you evaluate that, you find that's equal to 19.9 feet squared area. Make sure you include your units. And so this would be the area of that triangle. So it's area using side, side, side. Last thing, I want you to be able to draw these. So you can try drawing each one of these and then try to figure out which law would you use, law of sine or law of cosine. And then what's the first piece of information you would find. So I would pause it if I were you before I show you the answers. Which law, and then what's the first thing you'd find. So go ahead and do that now. So here are the solutions. For this one, it's angle, side, or side, angle. So you could first find the missing angle, C. So once we have C, then we have the angle opposite of side, then we can use law of sine. For this one, we have side, side, angle. And so we have the angle opposite the side, or we could call that angle side, side. So this is the tough one. This is the one that's a pain. So you use law of sines, but you first need to check your height to see how many triangles we have. In C, we have side, 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 so you can use law of cosine, but you want to find the largest angle first, so you need to find angle C. 29 is the largest side, so angle C is going to be the largest. And then the last one here, we have side, side, angle. We have to use law of cosine here. And then you're going to use law of cosine twice. So you're going to use law of cosine to find your side B. And then you're going to use law of cosine with the three sides to find the largest angle that's left. And so these are 4 different kind of options you would have. And so hopefully you can draw these out. If you have questions, we can talk about tomorrow. Have a good night.